statistically as well. Somebody had a question. Yes, ma'am. I can't hear. Really loud. I'm going to talk about that in just a moment. You're right, it can be, and I have to take precaution. She was asking, can a face-to-face survey sometimes be intimidating, or might people not answer accurately? Yes, that does happen, and we have to take certain measures to ensure that our results are not compromised from that.
That's good too. It's just that.
Now, as I mentioned earlier, we want the responses to be valid. In fact, I'll get into this right now, responding to your question. That is to say, we want them to actually measure what we think, what they're supposed to measure. And we can do a number of things to guard against several dangers that compromise the validity of responses. So I want to talk about these threats to validity and how we deal with them. One threat to validity is undercounting. I've already talked about that. Due to an imperfect sampling frame. I may, in other words, have a sampling frame that excludes a part of the population. And if it excludes an important part of the population, then the results are going to be invalid. I gave the example of my interest in studying the religious behavior of Canadians. I sampled only people who belong to religious institutions. The results about the level of religiosity in Canada that I get from the survey would be invalid, because I'm not taking into account the very large number of people who don't belong to religious institutions. I would be undercounting a very important group of the population. Now we get to the question that this woman asked a moment ago. Some people may not answer some or all of the questions. That is to say, the survey may suffer from non-response. Why did non-response occur? Well, it may be that the respondent and the interviewer differ in important ways that make non-response more likely. For example, let's say that I'm interested in doing a study of racial prejudice in Canada. Racial prejudice against blacks in Canada. And I'm a white interviewer. And I go and I knock on the door of somebody who's home, somebody's home. The person I know is a black person because of my sampling procedure. They know that I'm coming. I start asking them questions about, I should have done it in reverse. I'm a black interviewer. I'm going to a white person's home to ask them questions about how they feel about black people, how they behave with respect to black people, and so on. Will the white person likely answer completely honestly? If there's a black interviewer to these questions, these sensitive questions about race, it's not likely. There's going to be some bias there, because the white person is going to give socially acceptable responses, not valid responses, not accurate responses. In such a situation, therefore, if I'm asking about a question, which is likely to be sensitive and bias the responses of the respondent, I'll want to make sure that the interviewer I send to that person is a white person, not a black person. Then the person is more likely to answer frankly his or her beliefs about black people, or the way that he or she acts towards black people. Okay, there's some assurance there that I will increase validity if I match the respondent and the interviewer on race. That's one thing I can do. What else can I do? Well, I can increase validity if I do the following kinds of things. I tell people in advance that the survey will be conducted. If I inform people in advance that they've been selected by a prestigious institution, like the University of Toronto, say, not just some marketing agency or something, people are going to be more likely to respond and agree to participate in the survey. They're going to be more likely to participate in the survey if I explain the significance of the survey This will help us improve the educational system of the city of Toronto. We will use your opinions to help us formulate policy. Many adults will say, well, look, it's a worthwhile thing. It's worth an hour of my time. And we've also increased the response rate by ensuring that we give small rewards to people for participating in the survey. We might give them a lottery ticket or $1 or a toonie or something like that in gratitude for participating. Small gifts like that actually do increase the response rate and cause people to answer more frankly. So I was also recognized, finally, that there may be response bias when people don't answer completely accurately because these questions are so sensitive. If I want to do a survey about alcoholism, and I ask a random sample of the population how many drinks they have a day, do they ever get to engage in binge drinking, defined as having 5 or more drinks within 1 hour. If I ask them questions like that, alcoholics are less likely to answer those questions frankly because this is a very sensitive topic to them, and they don't want to necessarily publicize their behavior. In such circumstances, I may want to do something like this. I may want to, when I get to the sensitive questions part of my survey, I may want to pull out a piece of paper and an envelope and say, look, here's the questions I want you to answer in private. You don't have to tell me your responses. When you're finished, put them in this envelope, seal the envelope. You see here I have 20 other envelopes from previous interviews. I've already signed up, you've already signed off on this, I've signed off on it. You know that the responses that you give are anonymous. They'll only be used for statistical purposes. There's no way we can ever identify you. So what's going to happen is I'm going to take your sealed envelope. When I get back to the office, I will enter data on all of these questionnaires into my computer, and there'll be no way of knowing who gave what response. So it's all going to be done in confidence. Nobody will know your responses. So if I ask questions about sensitive issues like child discipline or alcoholism or criminal behavior and so on, I might want to do something like that to avoid response bias. And finally, last point, we can increase the validity of questionnaires by avoiding the wording effects. That is to say, we have to word questions in a certain way in order to ensure that we're getting valid responses. First of all, questions have to be specific. They have to be about one thing and one thing only. You can't ask about multiple things, or the nature of the response is confused necessarily. You don't really know what they're answering about. It has to be phrased simply and in a neutral way. You can't ask a leading question, right, which will invite a particular kind of response. And we should focus on events, or it will, the responses will be more valid, I should say, if the questions are worded in such a way that they focus on events that are important to the respondents, singular and current. If you're asking something about something that happened 5 years ago, and it's about something that's not very important to the respondent, then the response you get will have a higher invalidity. So these are all things that we can do to boost the validity of surveys. Now, we can conclude on the basis of what I said that a survey is not an ideal instrument for conducting exploratory research, in which you don't know much about a particular subject, and just sort of go out and try to find out what's going on. It can't provide the deep and sympathetic understanding that you gain from participant observation, which Adam and we talked about last week. But surveys do produce results from which we can confidently generalize, and if properly crafted, they provide valid answers of many sociologically important variables. And because they allow the same questions to be asked repeatedly in many surveys, surveys can enable researchers to establish the reliability of the measures quite easily. And now, I want to emphasize finally, in the 45 minutes that remain to me, one point and one point only, which I want you to pay very careful attention to. And it is that surveys are also very useful for establishing relationships among variables, for finding out how different variables are associated, including establishing cause and effect relationships. In order to develop this point, that surveys can help us see the relationships among variables and whether there are cause and effect relationships in existence, I first of all want you to remember how causality is established with experiments, the point I began today's lecture with. We randomly assign individuals to experimental and control groups many times, making the sum total of experimental subjects and the sum total of controlled subjects identical in all respects except for one. Only the experimental subjects are exposed to the stimulus that interests us, the independent variable. All irrelevant variables have been removed from the situation through randomization. Well, in surveys, also, we can examine the effects of independent variables on dependent variables, but we do so in a different way. Not by randomly placing people in experimental and control groups, but rather by manipulating the data in particular ways. And I want to talk a little bit about how we manipulate the data in certain ways that enable us to establish the existence of relationships, including cause and effect relationships. And please remember, when I talk about manipulating the data, I don't mean fudging the data or lying about the data. I mean simply organizing it in certain ways that will enable us to see whether or not relationships exist among variables. Now, one of the most elementary yet very useful tools for determining whether variables are related in a survey and seeing whether they are cause and effect relationships is a contingency table. A contingency table. Very important term. Contingency table, write this down, is a cross-classification of cases by at least two variables that allows you to see how, if at all, the variables are associated. I'm going to explain this in a lot of detail, but I want you to get the definition. A contingency table is a cross-classification of cases. You know what I mean by a case? If I've got 1,500 people in a sample, I've got 1,500 cases. If I'm analyzing countries, I'm looking at all 207 countries in the world, I've got 207 cases. Okay? So a cross-classification of cases by at least two variables that allows us to see how, if at all, certain variables of interest are associated. That's what a contingency table is. And now, allow me to explain. Let's say you want to test the hypothesis that the number of hours a person spends watching television every week increases the frequency of that person's violent behavior. Let's say you got this hypothesis. The more TV a person watches, the more likely they are to act violently in everyday life. First of all, what's the independent variable? Hours of watching TV. Actually, watching TV, or hours of watching TV is the independent variable. The dependent variable is violent behavior in the real world. Okay? One's the presumed cause, the independent variable, the other is the presumed effect, the dependent variable. So, let's say I want to test this. And let's assume, please, for the moment that all of you will answer my questions completely validly without any distortion or any other problem. Let's say I ask all of the students in this class who watch TV more than 10 hours a week to stand by the right wall. Go over there. Don't actually do it. Let's just say that I would ask everybody who watches more than 10 hours of TV a week to go to the right wall, and all other students to stand by this left wall. So I'm dividing you into two groups, those who watch 10 or more hours of TV a week, and those who watch less than that. And then, let's say that I ask all of the students who committed at least one act of physical violence against another person in the past year to move to the front of the room. Remember, you're all very honest people. You're not going to tell any lies or just not fail to disclose the truth. So if anybody committed an act of violence in the past year, you come to the front of the room. That is an act of violence against another person, and everybody else goes to the back of the room, right? So now I have people clustered. We're imagining this is a square or at least a rectangular room. We now have people clustered in the corners, right? In one corner, we've got people who watch a lot of TV and committed an act of violence. In another corner, we've got people who didn't watch much TV and committed an act of violence. In another corner, we've got people who didn't watch much TV and committed an act of violence, and people who didn't watch TV and didn't commit an act of violence in that corner over there. What we just did is we created a contingency table. We have cross-classified cases, by two variables simultaneously. Whether you watch a lot of TV or a little TV, and whether you committed an act of violence or didn't in the past year. That's all that a contingency table does. Cross-classifies cases by at least two variables. Here's a picture of what we just did. Okay, here are the four corners of the room. Anybody not see this? Because it's going to get more complicated in a moment. Everybody clear on this? Okay. Now, there is an association between two variables if the value of one variable changes with the value of the other. So, for example, if one variable increases and another variable increases with it, we say there's an association. Or if one variable increases and the other one decreases, there's an association. If one variable increases and the other one doesn't, as one variable increases, we say there is no association. Okay? There's no relationship. For example, if the percentage of students who committed an act of physical violence in the past year is higher among frequent TV viewers than among infrequent TV viewers, there is an association between the two variables. And the greater the percentage difference, perhaps the most important sentence that I'm going to be uttering today, and I'll explain it at some length, the greater the percentage difference between frequent and infrequent TV viewers, the stronger the association. Okay, let's go back for a minute. I showed you this contingency table as a picture. Now I'm going to show you as a table what this might look like. Okay? Here is a contingency table. I've got two variables in it. Amount of TV viewing and aggressiveness as measured by acts of physical violence against another person in the past year. When you see a table like this, the very first thing you need to do is this. Note the direction in which the table is percentaged. See the 100 at the bottom? That tells you the direction in which the table is percentaged. What does this table say? Well, it says there's a bunch of individuals who are cross-classified by these two variables, right? And those core cells in this table that I circled in red shows you the percentage of cases in each column that fall into a category of each row variable. Remember, please, that a column, like in a building, goes up and down. Okay? A row goes across this way. So what this table says, just look at that 52 for a moment. It says that 52%, how do I know it's a percent? Because it says in the title, in percent, right? So I know 52% of the people who watch less than 10 hours of TV per week committed less than one violent act per year. That is 0 violent acts per year. It also says that 46% of the people who watch 10 or more hours of television per week committed less than one violent act per year. It does not say that 52% of the people who committed less than one violent act per year watched less than 10 hours of TV per week. How do I know that? How do I know what it says? I'm looking at the percentage of people who watched less than a certain amount of TV or more than a certain amount of TV because I took step one. I first of all noted the direction in which the table is percentage. I know that those percentages are percentage of the people who watch less than 10 hours per week or people who watch 10 or more hours per week. Therefore, who wants to tell me what the 54 means? 54% of people who watch 10 or more hours of TV per week did what? Committed one or more violent acts per year. Okay? So that's very important. You understand the difference between a column and a row. You understand the direction in which a table is percentage. And you know that those core cells, those percentages in this case, refer to the variable that is at the head of a column that is percentage, that adds up to 100%. Those numbers at the bottom, total frequency, N in parentheses. That's the number of cases in each column. In other words, 52% of 130 people, or 46% of 70 people. There are 70 individuals. That would means that I can calculate how many people are represented by that 52%, couldn't I? If I wanted to know how many individuals that 52% represents, how could I figure that out? Take 52% of 130. There's 130 people in that column, 52% of them, whatever it works out to. That's why you need to bring a calculator to your final exam, because you might be asked to do that. Okay? A non-programmable calculator. In other words, if you can enter any, you can say that the value of X is this and the value of Y is that, and let the computer do a calculation, the calculator will not be allowed. It has to be just a simple $5 calculator that allows you to add, subtract, multiply, and divide. Okay? So, this row of numbers here, total frequency, or N, is the number of individuals in each column. And, as I said earlier, that last row of data is total percent, the percentage of people in each column. So that 130 represents 100% of the people who watch less than 10 hours per week. Any questions so far? Yes, sir? Yes. Yeah, well, no, actually. Because usually that's true. In other words, usually what happens is that the independent variable is along the top of the table. Okay, it's arrayed horizontally along the top. That's the independent variable here, TV view. And the dependent variable is on the side. Right? And in that case, we know what you just said, namely that the independent variable adds up to 100%. Sometimes people percentage a different way, the opposite way. And we can be sure of one thing, that if we understand where the hundreds are, where the percentage is, we'll understand the orientation of the behavior of the table. We'll understand what those percentages are percentages of. And we'll understand the difference between saying that the 52 is a percent of those who watch less than 10 hours of TV per week, and saying that 52 represents the percentage of those who commit less than one violent act per year. There is a difference. You have to know which way is percentage in order to make sense of this table. Final thing about this table, the percentage difference. The percentage difference is a statistic. It's the simplest statistic you can think of. All it does is it calculates the difference between one of the cells and the cell right beside it, horizontally. So the difference between 52 and 46 is 6. And the difference between 48 and 54 is 6. That's the percentage difference. The higher the percentage difference, the stronger the association between the two variables. If that percentage difference was 0, there would be no percentage difference. If that were the case, because it would be a 50 and a 50 in that top row, the percentage difference would be 0. It would mean that there's no difference. The TV viewing, the amount of TV viewing has no effect on whether or not you commit less than 1 act of violence per year. If the number were bigger than 6, it would mean that the association between these two variables is even stronger than it is in this table. The bigger the percentage difference, the greater the effect of the independent variable on the dependent variable. Okay? This is a very simple way of thinking about correlation. Okay? Anybody not understand that? You're all clear on this? Okay. So, can I conclude at this point that there is an association here between TV viewing and committing acts of violence in this made-up data? Is there an association? Anyone? Hello? Yes, there is an association. If there's a percentage difference, there is some association. There's a difference between the number of violent acts committed by those who watch a lot of TV, between those who watch a lot of TV and those who watch less TV. 52% of those who watch less than 10 hours of TV per week commit less than 1 violent act a year. But 46% of those who watch more than 10 hours of TV per week commit less than 1 violent act per year. It means that you're less likely to commit no violent acts if you watch less TV. Right? That first row of data. The second row of data says just the opposite. In a way, if you watch more TV, you're 6% more likely, in this case, 6 percentage points more likely to commit 1 or more acts of violence per year. The percentage difference is 6%. I'm sure you understand that. So, that was my first question. Is there an association? Answer, yes. There is a percentage difference. Next question. Is this a cause and effect relationship? No. Not necessarily. One no, one not necessarily. Why not?
He's still in the horse mask on.
Let's hear from not necessarily back. So should we go home now? I'm not going to worry about percent error now. Somebody else said she wants me to add control. What does that mean to you? What control? Why? Well, possibly it matters what I watch on TV. What else? In other words, you don't understand what she's saying. Maybe this association isn't real. Maybe there's something else going on. Maybe there's some other extraneous variable, some other factor that accounts for this association. Remember, in an experiment, we got rid of all those extraneous variables, all those other background, all that background noise about whether or not gender influences the association we're interested in, or race, or ethnicity, or income, or education. We did that by randomizing. But here, we haven't got rid of anything. There may be 1,000 different reasons why that association exists. I'll give you one. Maybe men watch more violent TV than women. And maybe men are also brought up to be more violent people than women are. More aggressive. They play rougher. They're encouraged to do so. And that's expressed in greater physical violence. So maybe what's actually going on here is that the people who are watching a lot of TV, well, there's more men there than women who are watching a lot of TV. And actually, it's gender socialization that is causing this association to appear, not viewing television. So how would I find out if my hypothesis is accurate? If what's going on here is not that watching TV causes people